Now, in our study of biostatistics, this time we want to go to the area of proportions and percentages. This is actually part of what is supposed to be studied here, and a concept which is very important for anyone who deals with health sciences that involves numbers and things to be analyzed. Now, I would want us to begin with proportions, and these compare ratios, i.e. can be used to equate equivalent ratios for x, y, z, and w quantities. A proportion states that x is to y as z is to w, as given in this expression here. So this simply means that this ratio is equivalent to this other one. So when we compare ratios, we are talking about proportions, where in this case w is not supposed to be equal to 0. Now, proportions can be used to determine an unknown property or variable. In other words, you can find z given, x given, y given, z missing, and then we have w given. So you're supposed to find this value by doing that comparison. Now, example 1. You know that to make 20 pancakes, you have to use 2 eggs. That is known. How many eggs are needed to make 100 pancakes? So you want to compare what we have for the 2 eggs and the 20 pancakes compared to 100 pancakes. How many eggs are we going to find? Let's try to compare these cakes, and we have eggs 20, 2, 100, how many? So we start by thinking about what kind of relation that we are going to get in terms of proportions. If we needed 2 for 20, then we are likely to need more for 100. So this makes it that when we end up with this kind of ratio, the bigger value will be on top as the numerator and the smaller value at the denominator. Then you multiply by this 2 and it will give you this result, that is 0, 0, 2 into 10, 5 times 2, you get 10. Now, the other example, 5 ladies can prepare food for 20 persons in 2 hours. How many hours will 7 ladies take to prepare food for 30 persons? So you see, we are comparing ladies, persons, and hours. That's what we have here. So 5 attending to 20 takes 2 hours. 7 attending to 30 will take how many hours? We want to look for this dealing with the components of proportions. So we first ask ourselves, if 5 ladies took 2 hours, 7 will take less hours, not more, less hours. So when we are going to have less hours, then we want to treat this in terms of what value gets to the numerator and what value goes to the denominator. So because we are getting less, then we'll have the smaller value at the numerator, that's 5 over 7 times. Then you come to this part, you say, if for 20 persons 2 hours was spent, what about 30 people? That is likely to have more hours. So we'll have the greater value at the numerator divided by 20 times 2, which is the 2 hours. That is 15 over 7. This results to 2.14 hours. So we want to move on. Example 3. Find x in x over x plus 20 equals to 24 over 54. So these are comparing ratios, which is what we call proportions. So let's try to solve this. Now, we have to first simplify this relation. So we have x over x plus 20, which equals to 24 over 54. This can be simplified by dividing by 2. You get 12, 27. Further divide this by 3, you get 4, 9. So we end up with x over x plus 20 equals to 4 over 9. So this simply implies that when you cross multiply, this 9 times x will be 9x equal to 4 times x plus 20 is what we have here. Let's open this bracket and we'll get 9x equals to 4x plus 80. And this actually simply means I want to take or collect like terms, so we'll end up with 9x minus 4x. When this gets this side, it becomes negative, equals to 80, and therefore if you do that subtraction, you end up with 5x equal to 80. Divide throughout by 5, you get x as 16. Very simple. Let's talk about percentages. Ratio, rates, proportions, fractions, degrees, etc. can be expressed into percentage. To express ratio into percentage, you first find the total ratio. That is, if you have ratio 2 to 3, the total will be 2 plus 3 to get 5. So you need to find total ratio and then obtain the required ratio over the total. So if maybe the part of the ratio which I'm interested in is that 2, which will be over 5, then that is what we multiply by 100 to get the percentage contribution of that part of the ratio. To convert rates into percentage and vice versa, reasoning is required. That simply means that you need to first find how this rate is obtained, and then we want to get its percentage in terms of what. That is what you need to ask yourself for every situation. Now let's do this example. In a food test lab, there are 40 students, of which 8 are male. Determine the ratio of male to female and express the number of females as a percentage. So total is 40, male 8. We need to find female. So for females, that will be the total minus males 8 to get 32. The ratio of male to female is 8 to 32. Simplifying this, you get 1 to 4. That means 8 divides 32 4 times. So you end up with 1 to 4 for that ratio. Then when you want to now obtain the percentage female, that simply means we want to talk about what is this 4 over the total ratio, which is 5. That is, total ratio is 1 plus 5, which is 1 plus 4, which is 5. So 4 over 5 times 100 will give us 80% of the population there, or 80% of the total will represent female. Example 5. 30% of the population in a female ward suffer from malnutrition. Determine the ratio of those with the condition to those without. So in other words, we are talking about a condition of malnutrition in a ward, female ward to be specific, and 30% suffer from that. That simply means the other proportion is actually those who don't suffer is 100 minus 30, because the total percentage is 100. So if I have 30 suffering, 30 with a problem, then without is 100 minus 30, which is 70. Ratio is simply the 30 with the problem to the 70 without. And we don't leave ratios like this, it has to be simplified. So this simply gets to 3 to 7. We just divide it by 10, or you drop off the zeros, you end up with 3 to 7. These questions are that simple to let us understand the concept of proportions and percentages. And we want to end at that, hoping that we are going to learn more by our studies. And if you have questions, just type down there and let me know. Thank you.